Alright, so we're going to finish up section 1.3, and then we'll spend probably about 5 or 10 minutes on 1.4, just kind of as a refresher of slope and things like that. So the first thing they talk about in 1.3, part 2, is what's called the greatest integer function. The greatest integer function is it's like a formula that always gives you an integer as an answer. Specifically, what integer? The biggest integer that it can, that is less than or equal to the number that you plugged in. And the symbol for it in our book, you'll see this double bracket kind of thing on the calculator. I'll show you where it is, but we're going to be looking for something that says INT. For example, if I plugged in 7.3, what's the biggest integer you can think of that's less than 7.3? 7. How about 7.8? What's the biggest integer that's less than 7.8? 7. How about 7.9? 7. How about 8? 8. So notice all of a sudden it jumps. It jumps up. And because of the way it jumps, like in the range, all of a sudden you're getting answers that were 7s. Now we jumped up to 8s. It's going to have a very special look to it, and it's going to look like a series of steps that jump up. So if you plug in any number between 0 and 1, not including 1, the greatest integer that you can get between 0 and 1 is 0. If you plug in a number from 1 to 2, including 1, not including 2, the greatest integer that you could ever come up with for any number between 1 and 2 is 1. Okay, so it looks like a set of stairs. And if you want to graph this on the calculator can't do the open and the closed circle part of it, which technically is part of the graph, but it can at least do the stairs part. So to graph it, we go to y equals. If you have anything else in there, you can clear it. And the integer function, which is how it's written on the calculator, is under math. So you press math. And
is it FN? Is it 9?
No, 9 is greatest common.
Oh wait, or under math or
No, 5. I don't know why I couldn't see it. It's option 5.
Oh okay, or under number.
So you go to math, and then you go to the right to the number menu, and it's option 5. So if you put that in, it'll say int on the screen. And then we just need to put x. And if you put in x and do zoom 6, you're going to see exactly what we just had, a series of steps. So let's think about that graph for a little bit.
Put in what? Sorry, just x.
Int x.
Yeah.
Yep, x would be your argument to the function. Okay, that's known as a step function because it kind of looks like a series of steps. Now, if you have an older calculator, it might actually try to connect all those steps. So if your calculator did something like that, older calculators don't like to draw graphs that are not connected. Step functions are what we call discontinuous. You have to draw a step, lift your pencil, put it back down somewhere else. Calculators don't like to do that. So that's why it connected everything. Newer calculators can automatically handle the jumps. Notice it draws it slower because it has to think more about how to do it rather than just connecting it. But that's how it should look. All of mine should look that way automatically because my calculators are set to do that. If yours doesn't, it's just a setting we would have to change. Not a huge deal, but I can show you where it is. So we've already found a complete graph. I would say the standard window is fine.
Is that 10 by 10 or 20?
Yeah, that's the negative 10 to 10,
Yeah.
which is technically 20 units, and negative 10 to 10, which is another 20. So find a complete graph, standard window. What I'm more interested in is the domain and the range.
Yeah, I didn't do so hot on that.
So domain is what you can plug in. If you're doing the integer function, what numbers can you plug in? In other words, what numbers can you find an integer that is less than that number you plugged in? Any number. Yeah. So the domain here is all real numbers. What that essentially means, if you want to think about it visually, is if you made a vertical line and you started dragging it through your graph, is there anywhere that it would miss the graph completely? And the answer is no. No matter where you drag it, it will always hit the graph somewhere. If it does, then that means there are no gaps in the domain, and the domain is every real number.
Alright, I remember at one point we learned like a shorthand way to write all real numbers. It was like all, and then isn't there like a symbol for real? Is it like a curvy R or something?
So there's a couple different ways we can write it. This is called interval notation. I know the symbol you're talking about using the R.
Right. Yeah.
We'll use this notation, which means this is the lowest you can go, and this is the highest you can go. And we include everything in between. Whether you put a parenthesis or a bracket on the end of what this interval, it doesn't, in this case, it doesn't make sense to use a bracket, because when you write something like this, that would mean you could use every number between 3 and 4, including 3 and including 4. Well, this means to use every number between negative infinity and infinity in your domain. But you can't include infinity. Including it means you can reach it. I can reach 4. I can't reach infinity. So that's why you always put a parenthesis on infinity. Now, think about the range. If you made a horizontal line and you drag it through your picture, are there ever points where it misses the graph completely?
Yes.
Oh yeah, a bunch, like right there. So the range is not all real numbers. Does anyone think they know what the range is? Yep.
All integers?
Yes. Good job. All integers. You'll get every single integer in the range. No fractions, no decimals.
Could you quickly go over like the definition of domain and range again? Because I forgot what the difference is between.
Domain is what you plug into a formula. Range are the answers you get out from it. The domain is what you are allowed to plug in. Range are the answers you get out after you do the calculation of the formula. Any other questions on that? Okay, I'm not too worried about. Well, I guess we could try this one, just to practice domain and range one more time. So let's type in, I'm going to get rid of the integer function. I'm done with that. 16x minus x cubed.
How do you do cubed on that calculator?
The caret left with the division sign.
Yep, same way if you're used to using a scientific calculator, you use the caret, which is all the way on the right-hand side.
Okay.
And then once you hit the caret, your cursor is going to stay up in that exponent. So if you keep typing, it's staying in the exponent. If you have to type more, which we don't, after the exponent, if you hit the right arrow, it brings your cursor back down. Okay. Some people got their cursor stuck in the exponent. They didn't know how to get it out. That's how you get it out. Just press the right.
It for the homework, so just put a parenthesis x times x.
Yeah, if you didn't know any other way, you could do that. It would work. Right, let's do zoom 6. Now I'm going to give you a hint. This graph is connected. In other words, you never left your pencil to dry it. Do you think that's a good window?
No.
No, we need to go a little higher and a little lower to really see this. How much higher and lower? Just a guess. No, let's try like negative 30 to 30. If that's too little, I'll try negative 50 to 50. Again, I don't really know.
Oh, yeah, I did.
That's perfect. Right? That's exactly what we should see. And if you're wondering, well, is it going to turn again? Well, you can zoom out, a little more. I mean, you could try like negative 90 to 90 and look at it. But you can see it's not, now you're already looking at almost 200 units of Y value, and it's not turning again. This is just going to keep going up, and that will just keep going down. So what's the domain on this one? What numbers are you allowed to plug in for the X value here? Yep.
All real numbers.
All real numbers. The only time you have a problem with domain is if you are going to divide by 0 or you're going to take the square root of a negative. Those are the two things you can't do. And the range, again, I use the graph to really help me with this. Imagine putting a horizontal line and drag it through your picture. Is there anywhere where it misses the graph completely?
No.
No. So the range is also all real numbers. Domain and range.
There's not going to be any other way.
What's that?
No.
Any other questions on that? Yeah.
You said that the domain, you can't divide by 0 or what?
Or you can't take the square root of a negative.
Okay.
But there's no square roots in this formula, and there's no fractions. Like a divide by 0 would be something like this. I would say the domain here is every number except 2. And it would look like I showed you with that U symbol when you describe the domain. Everything except 2. So you can pick everything lower than 2. You can pick everything higher than 2. You can't pick 2 in that case.
Hey, divide by 0 or square root of a negative.
Yes. All right, so let's take a look at this problem. So this problem is going to be about a swimming pool that's 50 by 30. And there's going to be a sidewalk around the pool to keep it less complicated. The sidewalk is going to stay exactly the same width all the way around the pool. The area of the sidewalk is 600 square feet. And based on knowing the area and the size of the pool, I want to know what is the width of the sidewalk going around the pool. So there's a lot of information they give me in like a sentence format. But what do you think would be good to do to make this problem easier to think about? Yep? Yep, we're going to draw it up. So first thing I need to draw is a pool, rectangular pool. And I'm going to make it 30 by 50 feet. So let me start with that. So here is the pool. This is 30. That's 50. The next thing is I have a sidewalk going around the pool that's exactly the same width all the way around. So let me put a sidewalk around the pool. Okay, so here's sidewalk. Close enough. So there's my sidewalk. And it says that the width of the sidewalk is X. I'm not going to label it everywhere, but it's X all the way around each side of the sidewalk. The area of the sidewalk is 600 square feet. I'll call that A sub S. area of sidewalk. What's the width of the sidewalk? All right, so does anyone have an idea how I could find the area of the sidewalk? And I want you to think about it in terms of two rectangles. We'll say the green rectangle and the black rectangle.
What did the AS stand for?
Area of sidewalk. How could you write a formula for the area of the sidewalk in terms of the two rectangles up there, the green one and the black one? Yep.
Wouldn't you have to like subtract the area of like the pool? So you'd have like your big area minus well, yeah.
Yeah, keep going.
You have your total area.
So yeah, we'll call that the area of the green one.
Okay. And then it would equal the area. Oh. Is it not equal yet? I don't know.
Depends on how you write it.
Oh. It would be like total area minus the area of the pool.
And that would give me,
The area of only the sidewalk.
yes. That's the general idea. If you take the area of the green rectangle and subtract the pool, you will be left with the area of the sidewalk. So the area of the green, we can figure that, well, let's hold off on that one for a second. Let's do the area of the pool first. What's 30 times 50? Yep.
1,500.
So that's 1,500. The area of the sidewalk, we already know is 600. Now, by me asking the area of the pool, I assumed you knew the formula for the area of a rectangle. Just in case we don't remember, what's the formula for the area of a rectangle?
Base times height.
Yeah, base times height or length times width. So to find the area of the green, you need the length of the base. How long is the base of that green rectangle? I'll give you a hint if you're not sure. Yeah,
50 plus 2x.
50 plus 2x. And the height, very similarly, is 30 plus 2x. So let's do this out and see what we get. So when we multiply, remember you have to FOIL. 50 times 30 is 1,500, which is nice because something's going to cancel out. What's 50 times 2x? 100x. And what's 30 times 2x? So 160x and 2x times 2x. 4x squared. Bless you. Okay, so first thing we can do, does anybody see something that cancels out? Yep, so that's gone. And when you have an equation where the highest exponent of 2, what kind of equation is that? Remember that?
Quadratic.
It's a quadratic. So whenever you're solving a quadratic, you want that equal to 0. So we'd have 4x squared plus 160x. How would we get the 600 over on the other side? Subtract it. Now, whether I'm going to factor this or use quadratic formula, there is something I can do first to make these numbers a little easier to work with. Yeah? You can divide everything by 4. Necessary? No. Makes it easier? Yes. Now, I am going to give you a hint here. It does not factor. So, I think I just said it. But does anyone remember the other method you can use to solve something if a problem doesn't factor? Yep.
Quadratic equation.
Yep, you can use the quadratic equation. So remember your quadratic equation. And in this case, make sure we know what A, B, and C are. What's A? Has to be a number. A is what number? Yep. 1. B?
Why is it?
Oh, right.
Why is it 40?
40.
Negative
Negative 150. So when you plug that into quadratic formula, you're going to get negative 40 plus or minus 1600 minus 4AC. Well, 4 times A is 4. 4 times, let me do it one step at a time so you can see it. Minus 4 times A times C all over 2A. When you subtract a negative, that's going to become a positive. So I'm just going to make it a positive right now. And what's 150 times?
Wait, is that negative or positive?
It's positive now,
Oh,
because it's going to cancel with that other negative. What's 150 times 4?
Yep. 600.
So 600 plus 1600. I did that right. It should be 2200. And there are your answers. Now, quadratic equation always gives you 2, but there is only one width of the sidewalk, and that's what we're solving for. So one of these answers probably won't make sense, meaning it would be negative. Let's try the first one. Negative 40 plus the square root of 2200 divided by 2. We got a positive answer, 3.45. So that means if I were to do negative 40 minus the square root of 2200 over 2, it would come out negative. Algebraically, it makes sense, but for our word problem, a negative width of the sidewalk doesn't make sense. So we're just going to go with the positive, 3.45. And that's feet, 3.45 feet. Yeah, it's about 3.45 feet. So just a quick kind of reminder of how to solve a quadratic, in case that comes up. Any question on why I'm not worried about the other answer? I know it's going to be negative. Okay. Another concept that comes up, usually involving a quadratic, is what's called projectile motion. So in projectile motion, you're launching an object, and it's traveling in like an arc. And the formula that controls how that object is going to travel, specifically the height of the object, is right on the board. It's negative 16t squared plus v sub 0 t plus s sub 0. So there's a couple things that control how high, and this is the height.
is that S? I'm the CT.
Yes. There's a couple things that control how high the object is going to go. One is, well, how long has it been since you've thrown it? Because if you give it enough time, it'll reach its highest point, and then it'll come back down. How fast did you throw it initially? And what was the initial height you threw it at? For example, if you're standing on top of a building and you throw something off the building, well, you'd already maybe had 300 or 400 feet of initial height if you were on top of something. So we need to take that initial height into account. So initial velocity and initial height will always be given to you in the problem. It's important here that the units we use are feet per second, because if you wanted to use meters per second, which is more common in physics, you would have to change this number to something else.
Is that like a 0 in the down below, or is that a?
Yeah, S sub 0 and V sub 0. Just sub 0 on any variable usually means you're talking about time, and sub 0 means start value. Right, so that's the formula for projectile motion. So in our particular case, that's the problem. So we're shooting a rocket up from the ground at an initial velocity of 64 feet per second. So let's see if we can come up with an equation first, plugging in what we know from that problem into our equation. Well, that part always stays the same. Okay, what's my initial velocity? 64 feet per second. And what's my initial height?
0.
0. So I don't need to put plus 0 for the initial height. I can just leave it like that. Now this is a quadratic, so when we start to look at solving it, we could use quadratic formula. But I want to try doing it on the calculator and see what happens. If I want to know when the object will be 50 feet above the ground, where would the 50 feet get plugged in for? Would that go on the left-hand side, or would it go in for the t variable on the right? The left. Remember, S of t is the height. So we're going to replace this with 50. So we're going to have 50 equals negative 16t squared plus 64t. Now, I absolutely could solve that with quadratic formula. Get it equal to 0 and plug in a, b, and c to quadratic formula. If I want to solve this one using the graphing calculator, I want to find where 50, which is going to be a picture, equals negative 16t squared plus 64t. That's going to be another picture. What do you think I'm going to want to find once I draw both these pictures on the screen? The intercept. So we're going to, just like you did in the homework, you're going to put in a mark at 50. You're going to put in your equation, negative 16. You have to use x as the variable, just the way the calculator works. And we want to set our window. Does it make sense to have negative time in this situation? No. How about negative height? No. 0 is as low as it can go for time and height. So let's set the mins at zeros. Now, x controls the time. I don't know how long this object is in the air for. I'm going to say less than 10 seconds. I'm just going to leave it at the standard value. Y is the height. I don't know how high it's going to go. I don't think it's going to go as high as 90. I'm going to try 75. If my graph goes off the screen, I'm going to have to set it higher. Let's try it. There's a mark at 50. That's perfect. So at what time will the object be 50 feet above the ground? 2 times. On the way up, on the way down. So the first time is here. The second time is there. So what we need is the intersection point of both of those. So second calc, intersect. I'm just going to do the one on the right. I'll save the one on the left for you guys. So I'm going to do my blue, the red, and the guess does matter because you want to put the guess closer to the intersection point you're looking for. I want the one on the right. My guess is right on top of it already. So I don't know if you can read it. It says 2.94. That's on the way back down. Any questions on how you'd find the time on the way up?
Could you run through it? So
Yep. So you do second, calc, intersect. This time, before you do your guess, just move it. That's fine. I'm not right on top of it, but I'm closer to the one on the left. And now, it gives me the other one. So there's your two answers. 1.06 seconds. Now, one other thing they could ask in this kind of problem is, what is the highest the object ever goes? And the calculator can help us figure that out. It's something you would calculate. So we're going to go to second calc. And does anyone see an option there that you think would the maximum? Just like intersect, you have to hit enter 3 times. Let me show you how it works. So we're going to hit 4. And the first thing is, I need to make sure I'm on the right equation. Right now, it's trying to find the maximum of the blue graph. That's not the equation I want to be on. So either delete the blue one if it's confusing, go to y equals and get rid of it, or just press the up arrow, and now you're on the red one.
Ah, nice.
First thing it asks me for is left bound. You have to tell the calculator somewhere that you think is to the left of the maximum. So I'm going to move my cursor somewhere to the left. I'm going to hit enter. And then it asks for right bound. So I'm going to move my cursor somewhere to the right of the maximum. So what I just did is I told the calculator, look between here and here for the maximum. Just like an intersect, the last thing it'll ask me for is a guess. I'm going to move my cursor. Doesn't really matter in this case, but just move it close to the maximum. And because of rounding, you might get 1.9999999. I got 2.0000002.
Yeah.
Just depends on the calculator. But essentially, what is the maximum height of this object? 64. Yes. So 64 is the max height. So max height is 64 feet. And when does that happen? What's the time when you hit the maximum height? 2 seconds, yes. It is exactly 2 seconds. I know it says 2.000000002, but that's just the way the calculator works.
64
Feet. The max height is 64 feet, and that occurs at 2 seconds. Any questions on that? Okay. All right, so the last thing we're going to look at, and we're going to do pretty quick, is we're just going to review basically y equals mx plus b, slope, y-intercept. If you already know it, you don't have to write stuff down, because I'm going to go through it kind of quick. Sometimes I just skip the section altogether, but we've got about 15 minutes, so I'll quickly hit a few important things. y equals mx plus b. That's a linear equation in what we call slope-intercept form. Does anyone remember what the m stands for?
Oh, nope. I mean, what it stands for? No, never mind.
Yes.
The slope.
It's the slope. And how about the b? Yeah. The y-intercept, which means where your graph crosses the y-axis. That's your line. There's your y-intercept. That's your x-intercept. One way you can write a linear function is in the form y equals mx plus b. Generally, m has to be a number other than 0, because if m is 0, then it wipes out the mx. And now you have y equals b. That's called a constant function. That's a horizontal line. It's still a line, but according to our definition of a linear function, it doesn't fit the definition of a linear function by our book.
Alright, what did you say about, did you say that m can't be equal to 0?
Yeah, the m shouldn't be 0, otherwise you have what's called a constant function, not technically linear. So m can't be 0. But other than that, m and b can be any numbers you want. Real numbers, not imaginary or complex. What else? Yeah, we're not going to do the word problem. Slope. So slope tells you how steep a line is. And does anybody remember the formula for slope? If
Oh,
you're,
isn't it x1 plus x2 over y1 plus y2? Something similar? Maybe. I don't know.
not
I guess.
quite. It does have a fraction, though. There is a fraction. Little different numerator and denominator, though.
Okay.
Yeah?
Was it y2 minus y1 over x2?
Yeah. So that's your formula for slope. Sometimes people call it rise over run. Rise goes with the y's. The rise. Rise, y's. So I remember which ones go on the top. So that's how you can find slope. There are two special cases of slope. If you have a perfectly horizontal line, that has a slope of 0. The vertical line, we say that the slope is undefined. As far as examples, I'm going to save doing the examples, I think, mostly for the homework. They're quick, but I just kind of want to get through the vocabulary stuff, in case, and the formulas, in case you don't remember. And these are special cases with slope. They're also special cases how you write them. These are not y equals mx plus b. One of them is y equals a number. The other one is x equals a number. We've already done a lot of one of them on the graphing calculator when we're doing intersections. Yeah. Yeah, I'm going to write that down in a second. So, if I had a point 2, 3, and I wanted to find the equation of the horizontal line that goes through the point 2, 3. Horizontal lines always have an equation y equals a number. In this case, y equals what number would go through the point 2, 3? 3. Vertical lines, which you cannot graph on the calculator, always have the equation x equals a number. No, because they fail the vertical line test.
Oh.
Did we talk?
Yes.
We talked about that? Okay.
Yeah.
The calculator can only graph functions.
That's interesting.
In this case, what would x equal? 2. It's the vertical line at x equals 2. Now, sometimes you don't have equations in y equals mx plus b. Sometimes you have to rearrange them to get them there. And the advantage to rearranging this, so y is by itself, is that, I'll tell you in 1 second. So with a problem like this, you should feel comfortable doing something like this, and then rewriting it so y is by itself. What's the advantage of rewriting something with y by itself? Why would you want to do that? Yeah. Right, it makes it very easy to graph. If I wanted to graph this, and I specifically said to use the slope to graph it, well, unless you get y by itself, you don't have the slope. So now I know, put a 2, for my y-intercept, and then from there, go down 2, right 3, rise over run. Down 2, right 3, and I can draw my line very easily. So you should be able to rewrite something in y equals mx plus b format if it's not. Another way we can write the equation of a line is point slope. Point slope is useful if they give you a point like 5, 2 and a slope 3, and they say find an equation of the line that goes through that particular point and has that slope. You can use point slope. So like in this problem, it says find an equation of a line with a slope of a half, and it goes through the point -2, -2, +3. This is x1 and y1. Basically fill in the m, the x1 and the y1, and you simplify. Y minus 3 equals 1/2 x plus 2. -2, 3. And that's it. If that's all they asked you to do, you can leave your answer just like that. If they asked you to write your answer in y equals mx plus b, then you'd have to distribute out and add the 3. But they didn't ask us to do that. So we did y equals mx plus b. We did point slope. This is called the general form of an equation of a line. We don't use it that much. The only time I really get something equal to 0 is if I have a quadratic. Then that's what you want to get it equal to 0. But if you see something written in the form, ax plus by plus c equals 0, that's called the general form. Let's see, parallel lines. What has to happen for two lines to be parallel? Yep, Jameson?
Slopes have to be the same.
Slopes are the same. Yeah?
Never intersect.
Okay, never intersect. So, if they never intersect, the slopes would be the same and different y-intercepts, yeah. So parallel lines have to have the same slope and different y-intercepts. Does anyone remember what perpendicular is? It has nothing to do with the intercepts. It's just the slopes. Sam? Yep. So for perpendicular lines, the slopes are opposite reciprocals. So if I ask you to find the equation of a line parallel or perpendicular to something, step one is find the slope, because that's going to be very important. So if I said write an equation parallel to 3x minus 2y equals 1, and it has to go through the point 1, -2. Well, first step, I'm going to get y by itself so I can find the slope of this line. There we go. So that's not the answer. That's the same line rewritten in y equals mx plus b. Now I know, okay, he wants something parallel, so that means my new line is going to have a slope of 3/2, and it's going to pass through those two coordinates. I would just use point slope just like we did right here. Just fill in the slope that I just found and the point that they gave me. If they said they wanted it perpendicular instead of parallel, all I would do is take that slope, flip it, and make it negative. And it would be a negative 2/3. That would be my slope. This would still be my point. That wouldn't change. I would just have to change my slope.
Wait, can you leave the...
And the last thing, this finishes the section, is an inequality where you either shade above, or shade below. So for example, I'm not even going to go through all the rules, but if you wanted to do this in graph,
It's going to be like that one.
what's that?
Graphing inequalities is like going to be...
Yeah. What do you think you'd have to do first to graph this? Get it in like y equals mx plus b. So y is less than, what would be my slope?
2.
Yeah.
So you're going to bring that x to the other side, it becomes negative 2, and then you're going to divide by 3. And my y-intercept?
4 divided by 3 also, right?
4 divided by 3. So to graph this, it's not that much harder than graphing a line. You've got to, the y-intercept's kind of annoying, but it's 4/3. So that's 1.3. We're going to go down 2 and right 3. So down 2, right 3. Down 2, right 3. Good enough. But what we have to decide is, what kind of line do we use? Do we use a solid line, or do we use a dotted line? If you have an equal to in your inequality symbol, solid. No equal to, dotted, or dashed. So in my problem, is this solid or a dashed line? It's going to be dashed. It's not perfect. It's good enough. Last thing we do is we either shade above or we shade below. When you see a less than symbol, you shade. I'll just write it here. Less than or equal to, shade below. Greater than or equal to, shade above. So where am I going to shade for this one? Below.
It was solid for greater than or equal to and dotted for...
Yeah. Okay, so I know that was really quick on 1.4, but hopefully there was nothing there that was super new. We'll go over it when we do the homework tomorrow if there's any questions. Well, let me put the homework up, but I am going to take a question out. Okay, on page 31, give me 1 second to take one of the questions out. Okay, yeah, we're going to skip 45 and 46. So it skips around, so 32 to 37, 50 to 52, 55 to 57, that's page 31. And then page 42, again, it just kind of skips around. Okay. So it's probably like 18, might be like 18 questions or something. Okay. And we'll take a look at that first thing tomorrow.